basic operations on discrete time signals. Means how to operate on the discrete time signals. So there are operations like the operations are like time delaying, time advancing, folding, time scaling, and scaling. So we'll see one by one what is by time delay. If suppose time delay, if suppose x of n is a signal, any signal, then if it is delayed by k units, then it is represented as x of n minus k. So this is nothing but the representation of signal in time delaying format. X of n is the signal, and if it is delayed by k units, then it is x of n minus k. In case of time delay, you have to shift the signal. You have to shift the signal, towards right, by k units. So in shifting the signal, means time delay, in case of delay, you have to shift signal towards right by k units. I will draw, for example, if suppose the signal is 0, this is 1, then 2, this is nothing but n values, and signal is at 1, it is value is 2, it is value is 3, and this value is 4. And if suppose it is written as x of n, and you want to find x of n minus 3, so it means you have to shift the signal from 0, means the whatever value at 0, that will be shifted by 3 units, next value is shifted by 3 units, next value is shifted by 3 units. So that, so you have to plot 0, 1, this is nothing but the time axis I am drawing, 4, 5 and 6, that is n values. So the value at the 0, that will shift by 3 units, means 1, 2, 3. So that value will be drawn. So this is nothing but a value drawn at 3, then next value is 3, next value is 4. So this is nothing but x of n minus 3. So shifting time delay means it is shift signal towards right by k units. So those are the k units, means 3 units. Here it is shifted by 3 units. Next is time advancing. So in time advancing, if suppose x of n is any signal given, then the time advancing is by k units. It is represented by x of n plus k. X of n, it is time advanced by k units, x of n plus k. So in time advancing, you have to shift the signal, towards left side by k units. You have to shift towards, this is nothing but your, this is left side and this is right side. So you have to shift, if it is advanced, you have to shift the signal towards left. If it is delay, you have to shift to left. Suppose I am drawing signal, it is 1, then 2, then 3, it is at 0, 1, 2, if suppose it is x of n, and you want to find x of n plus 1. So it is n axis, so 0, 1, 2, this is minus, minus 1, minus 2. So in plus 1 means you have to shift towards by 1 unit. So this value whatever at 1, this will be shifted to minus 1. Next value 2, it is shifted to 0. And this 3 value it is shifted to 1. So you can represent x of n, if suppose x of n is represented like this, 1, 2, 3, and this is the origin shown, then x of n plus 1 it is represented as 1, 2, 3, but the origin is shifted to 2 because you are shifting this time advancing. Now next operation is folding. Folding means, folding is nothing but it is the mirror image of the mirror image about y-axis, mirror image about y-axis. For example, if any signal you have, you have to, if you are folding, if suppose this is signal, you are folding means you are finding the mirror image. This is the mirror image about y-axis. So in case of folding, if suppose x of n is given any value and you want to fold it, then it is represented as x of minus n. This is measurement notation for folding. We will take example. If suppose x of n, this is 0, 1, 2, 3, and at this 0 value is 1, at this 2 it is 1, it is 2, and it is 3. This is known as x of n. Then x of minus n is represented as, if it is 0, 1, 2, it is minus 1, minus 2, then whatever value at 0 that will remain at the same place, 1, whatever value at 1 it will be replaced at minus 1 and it is at 3. So that if suppose x of n is represented as 1, 2, 3, this is suppose origin, then x of minus n is represented as 3, 2, 1, and that is the origin. Remaining values are 0. So this is about folding of the signal, that is nothing but finding mirror image. Then it is time and magnitude scaling. We will take first time. If suppose x of n is a signal given, then time scaling may be x of 2n or x of 3n, etc. So if suppose any signal n and x of n, and it is suppose like this 1, 2, and 3, and it is 0, 1, 2, then x of 2n means you have to put 0, so the value will come at 0, it is n, and it is x of 2n, the value at 0 will be 1, put 1, then it is 2 value 2, so it is 3, so this is nothing but x of 2n. So this is called as time compression, and then if suppose x of n by 2, then this is called as time expansion. Similarly, magnitude, in case of magnitude, if x of n is the any value, then the magnitude can be increased by multiplying any factor, if suppose 2 into x of n. So it will increase the magnitude. If it is x of n multiplied by 1 by 2 or 0.5, it will decrease the value or magnitude. If suppose magnitude at this place is 2, and if it is multiplied by 2, it is x of n, then the value will become at this location will be 4. So this is time, this is magnitude scaling.